And I think I finally got my thingy to work again. Not sure what I was doing wrong. So
Yeah, I think that thing has to be able to see your receiver wherever it's plugged in.
yeah,
If it's blocked off, it doesn't work well. I've discovered that when I was filling over last week's material at the house.
well, it's still working. So it's not Bluetooth. I turned Bluetooth off.
Yeah,
Everybody see the slide?
I can see it.
Okay. So we're going to talk a little bit about schematic diagrams. Basically, they're uh, a vehicle or method that describes how a circuit works, how parts are interconnected, and it will show the components with schematic symbols, which are things you're going to have to learn, the interconnections between them, and they do try to standardize on symbols. So in most cases, you'll see the same symbol for a resistor or capacitor, or the basic components uh, look essentially the same regardless of who generated the schematic. Sometimes they will have part numbers. Uh, Usually they'll have the value of the component, not necessarily always the type component, because that's indicated by the symbol itself. This is a one I pulled, typical schematic for some little microprocessor, Sonat Mega, one of the Arduino family. Uh, Fairly typical of what you would see nowadays. So what is the name of an electrical wiring diagram that uses standard component symbols?
Schematic.
Charlie. Which of the following is accurately represented in electrical schematics? Any guesses out there?
C.
You have schematic representations of the components, not actual physical. And we'll get to those here in a slide or two. Basically, it shows the connection between the components. Here's some typical schematic symbols. The first one there is the representation for a resistor, and it's normally the three squiggles. The second one is a transistor. It's actually an NPN bipolar junction transistor. The third one is a lamp. It's not something you see much anymore, but in the old days, radios and things had little 12-volt pilot lights, like old flashlight battery or lights, things like that. And number 4 is a symbol for a battery. You can see the wide horizontal lines represent the positive end, and when it's a symbol like that, it typically indicates it's a multi-cell battery. And then number 5 is a ground symbol. You might see some different variations on those. But as far as the ARL is concerned, this is their ground symbol. So what is component 1 in this diagram?
Resistor.
All right. What is component 2?
Transistor.
All right. What's the function of component 2 in the drawing? Now, if you weren't here last week, you probably missed that. But it's Charlie, control flow of the current, which is what a transistor is used for. That either a current or voltage, depending on the type of transistor, can control the current through it. What is component 3?
C, a lamp.
Okay.
Or LED.
Well, we'll get to an LED, but we're not there yet. This is a incandescent lamp.
Oh, okay, thank you.
And what is component 4?
It's a battery.
All right. Okay, there's some more. So number 1 is a representation of an AC power plug. Number 2 is a fuse. Sometimes you will see that symbol with a little kind of a sine wave in it showing the fuse element itself. Number 3 is a switch. In this case, it's a single pole, single throw switch. Number 4 is representation for a transformer. It's 2 coils that are that have a common core, either air or ferrite, or in a big power transformer, it will be a special type of iron plates. 5 is a diode. 6 is a capacitor. They normally show that curved end on the ground side, even though those are not polarized capacitors. 7 would be another resistor. 8 is your light emitting diode. You see it's a regular diode symbol, but it has those little light rays coming out of it. 9 is a variable resistor, or sometimes called a potentiometer. It's a 3-terminal device. And 10 is a Zener diode. We talked about that a little bit last week, where the diodes have a special property when they're reverse biased. At a certain voltage, they will conduct in the reverse direction, and that's called the Zener voltage. So they can be manufactured with a very specific Zener voltage and used as voltage reference sources. When we talked about switches, that one diagram showed a single pole, single throw switch, which is up at the top. You'll also see a single pole double throw. So either, instead of being just open or closed, it makes contact with one or the other. So it can make contact with 2 different circuits. You also have a double pole single throw, which is like the first one, except there's 2 switches in parallel, and they're independent connection wise, but they move together. So they're either both open or closed. And then a double pole double throw, which again is a ganged version of the single pole double throw. So what type of switch is represented by component 3 in the figure?
A, single pole, single throw.
What is component 4?
D, transformer.
All right. Okay, we talked about diodes last week, and one of the uses for a diode is to perform rectification. And when we use them that way, we call them rectifiers. It's still a diode. And in that mode, it converts alternating current to a pulsing direct current because it doesn't change direction. It just varies in value from 0 to some peak value, which is on the chart on the bottom right. You'll see that gold line is the voltage coming out of the diode. And you see that it goes from 0 positive and then back to 0. So it doesn't conduct on the negative cycle of the sine wave. And the blue line is what's coming into the diode. Actually, in this case, it's into the transformer. So that transformer is actually increasing the voltage by 2 to 1. So which of the following devices or circuits changes an alternating current into a varying direct current?
B.
B. We talked about transformers, and that figure is kind of a typical power transformer was constructed. So we have that transformer core, which is made of some material that has a very high, usually permeability, which means its resistance to magnetic flow is very low. So we'll, in this case, we have a primary winding and a secondary winding, the red and the blue. So depending on the ratio of the number of turns will determine whether that's a step up, a step down, or what we call an isolation or a one-to-one transformer. So if it has the same number of turns, the voltage out is going to be the same as the voltage in. If you have more turns on the secondary than you have on the primary, it's going to have a higher voltage out than what's on the primary, and we call that a step up. Likewise, if it has less turns on the secondary, it'll be a step down and we'll get less voltage. That's what you would typically see in like a 12-volt power supply or something like a battery charger for a car, where it's plugged into 120 volts, but it's going to put out about 14 volts. So it would have a step down transformer in, as well as a rectifier. So what component changes 120 volt AC power to a lower AC voltage for other uses?
B, transformer.
All right. What is component 6 in figure T2?
B, capacitor.
All right. What is component 8?
D, light emitting diode.
I don't know why those little slide 1, slide 2 things are showing up. What is component 9?
Variable resistor. C.
Okay, one more set of diagrams. Here we have number 2, which is a variable capacitor. Number 3 is a variable inductor. And number 4 is a symbol, excuse me, for an antenna. You don't see too many variable capacitors in modern equipment. Those used to be mechanical devices that had a set of plates that rotated, interspersed with a fixed set of plates to vary the capacitance. Today, it's mostly done with varactor diodes, but it's still on the quiz. So what is component 3 in circuit T3?
Variable inductor. D.
Right. What is component 4?
A, antenna.
I really don't know what kind of antenna that's supposed to represent, but that's the symbol. Okay, so we learned schematic diagrams are used to show the interconnection of components that are represented with those specific diagrams. The transistors control the flow of current. Switches either open or close the circuit. Diodes used as rectifiers convert AC to pulsing DC. And transformers convert an AC voltage to a different AC voltage depending on the turns ratio.
I saw that they recently released a new extra question pool.
Yes.